Hello everyone, in this video we'll be looking at section 12.4, which is tangent vectors and normal vectors. So in the previous section, we learned that the velocity vector points in the direction of motion, right? In a couple of different examples, we figured out what the velocity vector valued function was, and then we plugged in a certain value and found the velocity vector at that spot. And if we looked at that, if we noticed every single time, the velocity vector, because it has a direction and magnitude, points in the direction of the motion, and its magnitude is equal to the speed. Right, but that's very specific for when we are looking at velocity of some object in motion. In general, not every curve represents that. So that observation, though, leads to this next definition, which applies to any smooth curve, not just those for which the parameter represents time. In other words, not just for those examples where it's some object moving out in space or along a plane curve. Okay, so the definition of a unit tangent vector. Let C be a smooth curve represented by r of t. It's a vector valued function. The unit tangent vector at time t is defined as t of t, right? And it's equal to the derivative of r over the magnitude of r, provided that the derivative of r is not equal to 0. In general, think about tangent vector, right? If I said find the equation of a line tangent to the curve at whatever value, so even if I was looking at just in the coordinate plane here, and I had like the curve y equals x squared, right? And I told you to find the tangent line right at this value. Remember, the tangent line is that line that has that just touches the graph right at that point. Right? That's still kind of the same idea here. But now the tangent is just going to be the kind of like how the velocity worked in the last section. It's just going to be that vector that touches right at that point, and it's tangent to the curve. Right tangent meaning because this is a right angle with the curve that points exactly inward. But that's the idea. Okay, so recall that a curve is smooth on an interval r prime when it's continuous and non-zero. So smoothness is sufficient to guarantee that a curve has a unit tangent vector. So as long as it's smooth, in other words, as long as its derivative is continuous on the interval that we're talking about here, then it has a unit tangent vector. So the reason why everything is making perfect sense with what we already know, because just think back to that example I was just looking at. If I told you to find the equation of the line tangent to the curve of y equals x squared, you take the derivative and then you'd find the slope at that point, right? Well, here, if I want to find the tangent, then the tangent is equal to the derivative, right? But it's a unit tangent, so that's why I divide by the magnitude of the vector, r prime. Okay, so again, since this is a unit vector, it has length 1. So now that we know that our definition, we know tangent matches up with the velocity from the previous section, and the tangents, just like we know and love from maybe even Calc 1 when we first learned about tangents. Let's go ahead and do an example. So let's find the unit tangent vector to the curve given by r of t equals ti plus t squared j when t equals to 1. Okay, so we need to find t of t. So in order to do that, we need to find r prime of t. Right, so that's just the derivative. So here I get I plus 2tj. And then I need the magnitude of r prime. So since it's a vector valued function, r prime of t is, the magnitude of r of t is just going to be a regular function of t, a real valued function of t, right? So it'll still have t's in it, or it could, but it will no longer have I and j's, right? And we just square each component and add them up and put it underneath the square root, right? So I get 1 squared, because 1's the coefficient here of I, plus 2t squared, so I get the square root of 1 plus 4t squared. So t of t, our unit tangent vector, is equal to r prime of t over the square root of r prime, over the magnitude of r prime of t. So it looks like 1 over the square root of 1 plus 4t squared, because that's 1 over the magnitude, times r prime of t, which is I plus 2tj. So in other words, it is, well, we could just leave it as that. And then now, what did the question ask? When t equals to 1. So when t equals to 1, the unit tangent vector is, we just go ahead and write, we plug in t equals 1 in here. So t of 1 is equal to 1 over, when I do that, I get square root of 5, and then I plus 2j. So I end up getting the square root, 1 over the square root of 5i plus 2 over the square root of 5j. Okay, so let's look at another example. Find the unit tangent vector to the helix given by r of t equals 2 cosine of t plus 2 sine of t plus tk at the point square root of 2, square root of 2, and pi over 4. So just as before, we need r prime of t. So in this case, I'm going to get negative 2 sine of ti plus 2 cosine of tj plus k. And now the magnitude of r prime is going to be negative 2 sine of t squared plus 2 cosine of t squared plus 1 squared. So this is going to give me 4 sine squared t plus 4 cosine squared t plus 1. So now if I factor out a 4, I'm left with sine squared t plus cosine squared t plus 1 underneath the square root. But sine squared plus cosine squared is equal to 1. So now I just get 4 times 1, which is 4 plus 1. So this is the square root of 5. So what does that mean? That means that my tangent, my unit tangent vector, which looks like the derivative over the magnitude of the derivative, is equal to 1 over the square root of 5 times minus 2 sine ti plus 2 cosine of tj plus k. Okay, and so now it says find the unit tangent vector at the point square root of 2 pi over 4. So at the point square root of 2, and pi over 4, we need to find the t value that corresponds to that, right? So in other words, right, this is my r of t, and this is my point on r of t. What t value gives me that point? Well, if I look, the easiest place to look is at the k spot, or at the third component there. If I plug in t equals pi over 4, I get pi over 4 in the third spot, and then I also get radical 2 over 2 times radical 2, radical 2 over 2 times 2, which would give me the radical 2's in the first and second component. So t equals pi over 4 is what I'm looking for here. All right? So what that means is at the point, that's what my t value is. So if I want to find the unit tangent at that point, I need to plug in pi over 4. So I get 1 over square root of 5 minus 2 sine at pi over 4 I plus 2 cosine at pi over 4 j plus k. 1 over radical 5 minus 2 sine at pi over 4 is radical 2 over 2I plus 2 cosine is radical 2 over 2j plus k. And now my 2's are going to cancel out. So I'd be left with 2 over 5 underneath the square root I plus, and I should have a minus there, so minus that, plus the square root of 2 over radical 5 there times j, plus 1 over radical 5 times k, if I wanted to go ahead and multiply it out. Okay, and so now the definition of the principal unit normal vector. Let C be a smooth curve represented by r of t, and if the t prime of t, which remember what is t prime of t, that is our unit tangent vector. So if our unit tangent vector is not equal to 0, then the principal unit normal vector at t is defined as n of t, which is t prime of t over the magnitude of t. So in other words, remember what is t prime of t? This one was given by r prime of t over the magnitude of r prime of t, right? So it's almost kind of like we're looking at the second derivative here. Not quite, but you get the idea that if we're given r, we need to go ahead and find the second derivative. Okay, so the unit normal vector is a vector orthogonal to the tangent vector of length 1. So that's how we interpret it. So again, it's kind of the analog of the acceleration vector in those examples from last section. Okay, so we want to find n of t and n of 1 for this guy here. Okay, so first we need to find t of t in order to find n of t. So in order to find t of t, we need to find r prime of t. Right? So this one looks like 3I plus 4tj. The magnitude of r prime of t is going to be 3 squared plus 4t squared underneath the square root, or 9 plus 16t squared underneath the square root. So t of t, which is equal to r prime of t over the magnitude of r prime of t, is equal to 1 over the square root of 9 plus 16t squared times 3I plus 4tj. Okay, and so now that I have t, I can find n of t, right? N of t means take the derivative of that. So to find t prime of t, we use its theorem 12.2. And I go, again, that's very specific. You're like, what is theorem 12.2? Well, if I'm going to go take the derivative of t, right, t is going to be this function here, which is a real valued function, times this function here, which is a vector valued function, right? So if I think of this as like maybe f of t, because it's just some real valued function, and I think of this as like v of t because it's some vector valued function, and I want to take the derivative of those two guys being multiplied together. Well, remember, this is what theorem 12.2 tells us, and I kind of talked about this when we went through that, but if I want to find t prime of t, and I have a real valued function times a vector valued function, I can really just do the product rule, right? So I could write this as f of t times v prime of t, or I can write it as, maybe it's better to do it this way, derivative of the first, so f prime of t, now leave v of t alone, plus leave f of t alone, times v prime of t, right? And that's the idea here that we're going to use to find t prime of t. So t prime of t take the derivative of f of t, or if I were to take the derivative of this guy, remember this looks like 9 plus 16t squared to the negative 1/2 power because it's square root in the denominator. So that would be negative 1/2 would come down if I took the square root, right? I could think about this as 9 plus 16t squared to the negative 1/2 times 3i plus 4tj. Right? So this one would be 9 plus 16t squared, and then if I bump the power down, it would be to the negative 3/2, and then I chain on the derivative of the inside, which is going to be 32t. And then now, so that was the derivative of f of t, so now I leave v of t alone, which is 3i plus 4tj. And then plus, now I leave f of t alone, so 1 over the square root of 9 plus 16t squared, and I multiply times the derivative of v, which is going to be 0i plus 4j. So now let's fix this up. So 2 and 32 give me 16, so I get negative 16 over top of 9 plus 16t squared to the 3/2, the positive because I threw it in the denominator. And then that's multiplied times 3i plus 4tj. And then plus 1 over the square root of 9 plus 16t squared times 0i plus 4j. All right, so I'm going to go ahead and combine this. Notice these are just two vectors, right? This is a vector and this is a vector. This is just the scalar out front. This is just the scalar out front, right? So let's combine the i's and the j's, right? So this is an I and this is an I. So if I go to combine that, I would take the negative 16 over 9 plus 16t squared to the 3/2 and multiply that times 3, and that goes in the I spot, right? So this one's 16 times 3 is going to give me 48. So I get negative 48 over top of 9 plus 16t squared to the 3/2. And then notice the other guy, this is a 0, right? So there's no other thing that adds together to get me I. So this is just my I component. So then now I'll do plus, and then we'll put some parentheses around this. So now I'm going to do my j's. So I want to add this j with this j, and remember I need to do this whole thing times 4, and then this whole thing times 4, well this whole thing times 4t, and that whole thing times 4. Right? So now what is 16 times 4t? Well, 16 times 4 is going to give me 64, so I would get I get negative 64 t over top of 9 plus 16t squared to the 3/2. And then now I'm going to add this other piece, right? 4 times this guy. So plus 4 over top of 9 plus 16t squared. I'm going to write that to the 1/2 power. So all of that times j. Okay. Now this guy right here, I'm not going to do it just to save us a little bit of time. I can combine these two using the common denominator. Which would be 9 plus 16t squared to the 3/2, right? Because 3/2 is bigger than 1/2, so it's the bigger denominator. So in other words, I just have to multiply this guy by 9 plus 16t squared, and that would get me to the 3/2, right? Because I have to do that in the top and the bottom. Now, if I did that, I combine them like terms. Notice 4 times 9 is going to give me 36. 4 times 16 is going to give me 64. Something's not working out the way I wanted it to. 64. full. Whoopsie. Here's why. Because this should have been 16t. I'll apologize. So this should have been a t right here as well. Because see, I've got this 32t, so that should have been a 16t. So that means that this guy right here should be 64t squared. And then this guy should be 48t. Right? So that makes sense because now I've got negative 64t, and when I distribute that, I would get positive 64t squared here, which cancel out with each other. So if I do that, oops, maybe I should do it in red, I end up getting negative 64t squared, which cancels out with the positive 64. So what ends up happening is my I is the same. So I get negative 48t over 9 plus 16t squared to the 3/2 I, and then plus I end up getting 36 over top of 9 plus 16t squared to the 3/2 j, and then now I can pull it out. The biggest numerator would be positive 12. Biggest denominator is going to be 9 plus 16t squared to the 3/2. And then if I pulled that out of each term, I'd be left with negative 48 divided by 12, because I pulled that out as 4, so I get negative 4ti, plus, if I pull out 12 from 36, I'd be left with 3, so 3j. So that is, all of that was to find t prime of t. Remember, we were trying to find the normal vector, right? So I need to find the magnitude of t prime of t. So I need to do everybody squared. So if I distributed this and squared it, is basically what I'm going to do here. So the first one would be 12 times negative 4t, right, all over 9 plus 16t squared to the 3/2. I'm squaring that because that's my first term, that's my I term. And then I have 12 times 3 over top of 9 plus 16t squared to the 3/2 squared underneath the square root. So now what do I end up getting? I'm going to leave the 12 squared alone because both terms have a 12 squared, so I'm going to be able to factor that out. And then I'm left with positive 16t squared over top of, when I square 3/2, I end up just with cubed, so 9 plus 16t squared cubed, plus, again, I'm going to leave the 12 squared out because I know I'm going to factor it out of both terms, and then times 9 over top of 9 plus 16t squared, and then cubed underneath the square root. So if I factored out the 12 squared out of both terms and took the square root, I'd be left with 12 here, right? And then I'd be left with 9 plus 16t squared over top of the common denominator, because this already has a common denominator, right? So that's why I could add the numerators together. 9 plus 16t squared cubed, right? But these two guys over top of each other are the exact same thing. That's why I rewrote it in opposite order with 9 plus 16t squared. So what that means is here, this whole 9 plus 16t squared cancels out with one of these factors. So I'm just left with squared in the denominator, 9 plus 16 squared. Well, I'm taking the square root of that, so I end up with 12 over 1, or 12 times 1 over 9 plus 16t squared. So in other words, 12 over 9 plus 16t squared. Okay, so then remember, what are we trying to find here? We're trying to find n of t. Well, n of t was equal to t prime of t over the magnitude of t prime of t. So the magnitude is 1 over. So in other words, I can flip this guy. This was the magnitude, right? 12 over 9 plus 16t squared. So I can flip it over. So I can rewrite that as 12 over 9 plus 16t squared. And then I'm going to multiply it times t prime, which t prime we found to be this. Right? So maybe we'll put a bracket here, a little bit bigger. Right? Because again, this guy is 1 over magnitude of t prime. So 12 cancels out with 12. One of these factors cancels out with this factor and makes it 1/2, right? Because 3/2 is just 1 times 9 plus is the 9 plus 16t squared to the first power times 9 plus 16t squared to the 1/2 power, right? This is 9 plus 16t squared times 9 plus 16t squared to the 1/2 gives me 3/2, right? So one of those factors cancels out. So I'm left with 1 over the square root, because I have 1/2 power in the denominator, 9 plus 16t squared times negative 4ti plus 3j. So that was n of t, which was one of the questions we were asked. And then the next question was n of 1. So at t equals 1, n of 1 is equal to, I would get 1 over 5, and then it would be negative 4i plus 3j, which would equal to negative 4/5 I plus 3/5 j. Okay, cool. And we have one more problem. Might as well just squeeze it into this video. So find the principal unit normal vector for the helix r of t equals to 2 cosine t plus 2 sine t plus tk. We actually already did part of this problem. So from example 2, we have what? So example 2, we found what t of t is, right? We found that it is this guy. So we know that. I'm going to go ahead and get rid of this. Scooch it over a little bit. So we know what t is. So now we need to find t prime of t. Remember how we find t prime of t? Well, I take the derivative of this and then leave the second guy alone, then the derivative of this, leave the first guy alone, right? So here, the derivative of 1 over the square root of 5 that's a constant, so that's 0. So just for completeness, I'm going to write it. So 2 times negative 2 sine ti plus 2 cosine tj plus k. And then now we do plus 1 over the square root of 5. Now we take the derivative, which is going to be negative 2 cosine ti minus 2 sine tj plus 0k. So this ends up being negative, we'll just write this as 1 over radical 5, or I guess I can rewrite it, so I can distribute that. So negative 2 over radical 5 cosine of ti minus 2 over radical 5 sine of tj. And 0k, which we really don't need that, so I'll just leave that off of there. So that is my t of t. So that means that the magnitude, right, that's the other thing we need to find our normal guy. So the magnitude of this, remember, we add everything up and square it. So I would have, I'll just write it out. So negative 2 over square root of 5 cosine of t squared plus negative 2 radical 5 sine of t squared underneath the square root. So here I would end up with 4 over 5 cosine squared t plus 4 over 5 sine squared t underneath the square root. If I factored out a 4/5 from each one of those terms, I end up with 4/5 and then take the square root of that, which give me 2 over radical 5. and then I'd be left with cosine squared t plus sine squared t. But what is cosine squared plus sine squared? That's 1. So this is just 2 over radical 5. Right? So n of t is equal to t prime of t over the magnitude of t prime of t. This won't ask us to find anything else. No, just ask us to find what it is. So here, again, I'm going to do this. I'm going to rewrite this as radical 5 over 2, because this is 1 divided by the magnitude of t prime of t, right? Because I flip it over. Now times t prime of t, which is negative 2 over radical 5 cosine of ti minus 2 radical 5 sine of tj. So if I do that, then I multiply everything out. I distribute this factor out front. So the 2's cancel out, so I was left with negative cosine of ti minus sine of tj. So that is what n of t is. And remember, what is n of t? N of t is our principal unit normal vector. All right, it's kind of like our acceleration. All right, that's all I have for this video. Thank you.